how Galera maintains that. Because anyway, I am writing one node. I am using one node to write. It needs to replicate to the other two nodes, right? So maybe this little bit delay is expected, right? That could happen. So in that situation, how the Galera is maintaining that. So that is, we will need to understand the flow control architecture. What is flow control? So there are few parameters related to that. So that will also, we will go through. So these are all the main topics we will cover in this Galera. So first of all, the Galera architecture and the basic setup and how to perform the failover with the proxy SQL thing that will also we will cover. And we will try to understand the Galera concepts. And yeah, so these are the main topics we will try to address in this Galera architecture. Okay, fine. So first of all, let's see how this transaction flow. So let's say, as I explained this asynchronous replication, we already know that architecture. We almost see in many sessions how it is happening. Even we see now also. That will write binary log, slave will read binary log, and it will get the data into relay log, it will be updated, right? So master will never mind about the transaction, whether it is slave applied or not, it will never check about it. Master will process its own transaction, the replica will read the relay binary log, and it will apply it, okay? It can be anytime, maybe 5 hours before one transaction happens in the master, my replication got broken or something. Later also, after 5 hours also, you can read the data from the binary log, right? Your transaction is not depends on the replicas with the traditional replication. But here in the Galera, so when it is providing the synchronous replication, we need to understand how it is managing. I mean, we need to understand that particular architecture, right? So for that, we will try to understand this diagram. So this is from the Galera documentation, galeracluster.com documentation. We have this diagram in the topic of certification-based replication. You can go through it. Okay, this is very useful to understand the architecture. Fine. So now let me try to explain this. So for example, let's say we have 3-node Galera cluster. Okay. Client is something as we are logging the MySQL client. And first thing is we are doing one update. Let's say I'm updating one table, T1 table, ID equal to 5. I'm doing that update. Okay. So when the update I started, let's say I do begin, I'm starting the transaction and I'm doing this update. First, when this, let me admit, 1 second. Yeah. So when the node 1, because I will connect any one of the node, right? Any one of the node, and I will trigger the update. So when I'm connecting the node 1 and I am starting this update statement, that update will process in the node 1 only. Okay, we know that how that update process, like it will go to the InnoDB buffer pool, it will check the ready page, it will check the page is exist or not. If it is not there, then it will go to the table space and get the page, then it will make the change. We see that architecture before that, I mean 2 sessions before, we see that InnoDB architecture, right? How that is happening. Fine. So yeah, we will also cover that in deep in the performance tuning session. So no issues on that. Now let's try to understand this. Client is connected to the node 1 and they are doing one update statement. So that node 1 will process the update. Okay, node 1 will process that update locally on the node 1 itself, and it will create the write set. Okay, it will not commit. Okay, it will just process the statement, but the statement is, the transaction is not committed yet. So when I'm running this update query, it will be processed in the node 1 and it will create the write set. Okay. So write set means it will contains the payload and the global ID for the transaction, table information, primary key value which are modified, those informations, all this information is available in the write sets. Okay, so payload means the exact row events. For example, if the update is modifying one row or two row, the payload will have all the, I'm just explaining the write sets, what are the contents inside the write set. Okay, so all the informations will be available in the write set. So when this write set is passing to the other two nodes, that is enough to create the same transaction in the other two nodes. So the write sets have all the informations about that transaction. Okay, that is the write set. So node 1 will process the statement or transaction and it will create the write set. It is not committed yet. Okay, just keep that in the mind. We are the client, we are triggering one update it to the node 1. Node 1 will process the update and it will create the write set. Write set will contains all the details about the transaction. Which are the rows modified from what to what, which are the tables involved, what is the statement. These are all the primary key value which are modified, table name, database name, all these informations will be available in the write set. Now the node 1 have this write sets here. Then it will tell, hey, we will get the okay. Okay. Once the node is the transaction is processed, we will get the okay. Let's say your update is completed. Now, when I am triggering the commit, right? Begin update statement. The next step is I'm connected to the node 1. Next step is I'm triggering the commit. During this commit, when the commit is triggered, then it needs to check the other nodes in the same cluster. Let's say we have three nodes, node 1, node 2, node 3 in the same Galera cluster. We connected the node 1 and executed the transaction. It is prepared the write set. We are also get the OK, rows affected OK, query OK, right? That we get it. And when I'm triggering the commit, what happens? It will replicate the write set, which created by the node 1. It will replicate the write set to the group. Okay, we have the GCS, which is the group communication system. This will be happen through the port 4567. Okay, for the Galera cluster, to set up the Galera cluster, we need these 4 ports to be opened. And this is one of the important port 4567. This is used to communicate within the group. Within the group means communicate within node 1, node 2, and node 3. Okay, within the group. So this communication from here to here, here to here, then back here to here, here to here, this all communication between the nodes will be happen through the port 4567. Okay, fine. Now what happened when we trigger the commit? What happened? The write set which is prepared by the node 1 will be published to the group. Okay, group means it is the other two nodes, node 2 and node 3. Okay, when it is published to the group, that will be received by node 2 and node 3. That write set which is prepared by node 1, that will be published to the group when we do the commit. Then node 2 and node 3 will get the write set from the group, and the both nodes needs to be certified that. So certified means, let's say this node 1 is processed ID equal to 5, which is the primary key value. Okay. Let's say in the same time, node 2 or node 3 also received the same ID equal to 5, same value. In that case, what happened? It will create the conflict within the group. Then the node will abort. We will face different kind of issues due to the duplicate value, because primary key will allow the, it will not allow the duplicate, right? So this certification means what it is. Node 3 and node 2 needs to tell the node 1, hey, we do not receive this transaction and we are not processing these IDs. This is not non-conflict transaction, so you can proceed. Okay, this is the certification. If the node 2 or node 3 already received the same ID value and they are processing the different transaction, then again they will tell, hey, don't commit this, because if you commit, we will have the conflict, because I am already processing the same primary key value, same data. So just about the transaction, it will decline the certification if the other two nodes are processing the same value in the same time. Okay. But if the other two nodes, node 2 and node 3, do not conflict with that write set which is published by the node 1, then they will give the certification positive certification. Okay. Let's say both given the certification okay, then what happened? It will commit. Node 1 will commit, and eventually the node 2 and node 3 will also commit the transaction. So we will get again the okay, your transaction is completed. No, transaction is completed successfully and it is applied on all the three nodes. Okay. Now, in case if there is any conflict which is already detected in the node 2 or node 3, then it will give the not okay certification. It will decline the certification. Then the other nodes, node 2 and node 3 also discard the transaction. And here, node 1, we need to roll back, because we already processed that statement and we created the write set, right? So here we cannot just discard, we need to roll back from our end. And the rollback will happen, and also we will receive the deadlock. Okay, in the node 1. So that is what maybe you may see some frequent deadlock in your Galera cluster in that sense. Mostly that happens in the multi-master. I mean, if you write on multiple nodes in the Galera cluster, then usually you will see many deadlocks, detected error, conflicts error in your error log. You can go through the error log with the verbose, you may see that. Okay. So this is how this synchronized replication works. It is quite easy to understand. So the node which is receiving the transaction will prepare the write set, and the write set will contain all the information about that particular transaction, like database name, table name, primary key value, and what are the changes. Then all this payload information, all this information will be available in the write set, and that write set will be published to the group, and the other nodes in the cluster will receive that write set and they need to certify. If the certify is okay, then it will be committed. If the certify is not okay, then there may be some conflict, so it will discard, and the node which is processed, there you will get the deadlock. Okay, so this is the how it is working. So here you see, for this replication, we don't need the binary log, right? So because this replication is happening based on the write sets, but for the traditional replication, we need the binary log, right? We write in the binary log, it will be read by the replica. That is how that works. Without binary log, you can not configure that replication. I mean the async traditional replication. But for this Galera replication, we don't need the binary log, because this replication is happening based on the write sets. Okay. So this is how this certification and the replication is happening within the Galera cluster. Okay, so this is the transaction flow and how it is getting committed. Fine. So now let's do the setup. Let's create the 3-node Galera cluster. And I also did not work out it today. I did not have time, so I'm also going to work out now only. Yeah, let's see. I think we can complete that setup, and then we will I will try to create some scenarios, like to create the flow control, what happens with the flow control, so how to control that. I will try to create some scenarios in the next classes. Okay, and we will also see the other topics like failover, all these concepts we will see. Fine. To set up the Galera cluster. Oh, I do not have terminal. Okay, I did not create a terminal as well. Or BCTL list. Okay, so I have created three nodes. One is the Galera 1, Galera 2, and Galera 3. We are going to use this three node to create the Galera cluster. Okay, so yeah, now let's try to log in. Or B-M, and this is 2, and this is third node. Okay, yeah, CD clear. So we are going to install the MariaDB Galera cluster in this session. Okay, if you are interested to see, there is no difference in much difference in the comparing to the Percona XtraDB cluster and MariaDB Galera cluster. So if you understand one, then mostly this parameters everything is same. There are little different. For example, for MariaDB Galera cluster, we use the SST method to Maria backup, but their Percona extra backup we will use for the Percona extra DB cluster. And there is no more much. There are some parameters we have additionally with the Percona server, which supports that will also supports the uh, Percona extra DB cluster. There are some minimal difference only. Apart from that, the setup is mostly 95%. All everything is same only. Okay. Now, let me switch to sudo. And first we need to set up the MariaDB repository. So we have the Jami machine, Ubuntu 22, which is the Jami machine we have. So we can visit the MariaDB official documentation. So there we have the MariaDB repository page. You can just type the MariaDB repository download. You can just click the first link. It will get you here. Okay. So here you can see there is one configuration tool. Yeah. MariaDB repository configuration tool. So you should let me admit 1 second. So just click this. So for MySQL, we go with the MySQL community server. There we can download all the packages, right? So usually for MariaDB, you can set up the repository, and using that you can install everything. So you need to select the distribution. So we have the 2204 Jami Ubuntu. So it's selected, and the version we are going to use 10.6. And mirror, I think you can choose any mirror. As we are in India, we can choose this needle gauge. That is fine. I think that will not impact much. So here are the commands to run to import the MariaDB repository key on your Ubuntu system. So let's run this. Okay. I think I need to bring this terminal to next. 1 second. Yeah. So it will be easy. Yeah, I'm running on all the three machines. So this is done. We are just installing the basic packages, curl, these things. Then we need to create this directory. Command, sorry, make there. What happened, man? Then we need to import this key, I think. Yeah, import this key, the repository key. Yeah, so this is downloaded now. Then once the key is imported, copy then paste the following info file inside this MariaDB sources. So this is actually the repository file. For example, for the CentOS and this Red Hat machines, we have the etc/m.repos.d. Inside that we have the .m files, right? That is the repository file. And for Ubuntu Debian, we need to use this. Let me create this file. Under the apt sources.list.d, we are creating the MariaDB.sources. And inside that, we just need to copy this content. So it will just have the link. For example, this is the repository. There is nothing much. We need to import the key to authenticate it. And here you can see in the repository, mostly we will have this link. I mean, where all the softwares are available because we choose in the 10.6, right? Here you can see MariaDB repo 10.6 Ubuntu. Inside that, all the packages will be available in this link. And we can use it. I mean, when we have this link configured in the repo file, we can search all the packages inside that in the server itself. That's it. So repository is just, it will create the link for the packages which are located in the website. Okay. Then we can just browse all the packages from the server itself and we can install whatever we want or uninstall whatever we don't need. Okay. Just we added the content, we created the repo file. Then they are asking to update. So whenever we do some modification in the repo file or we are adding some repository file, we need to do the apt-get update so that your repository will be updated with the machine, the Ubuntu machine. Then you can search all the packages. Okay, so this is done. Now we can search apt SEARCH MariaDB. So you will see all the packages now which are starting with the MariaDB. Okay, because we already configured the repo. Let me search MariaDB server, MariaDB-server. Yeah, so here you can see MariaDB server related packages. We just need to install this MariaDB server 10.6. Just do apt get install MariaDB server 10.6. It will find, so this is the benefit of repository installation. It will find all the dependencies and it will install everything for you. Okay, so this is one of the major advantage with the repository installation. If you are doing manually, like using the RPM bundle or you are doing with the source code, in that situation, you need to, you may go through a lot of errors. You need to fix them one by one. You need to install all the needed dependent packages. Then only finally you can install it, right? But with the repo installation, you can, I mean, a single command will take care all the things for you. We already see this in the installation first class, right? That installation with repo and bundle and the source code. So there we downloaded and installed different packages. Fine. So the installation is quite simple. For the MariaDB, we just configure the repo and we just installed it, right? And you can see now we are in the server MariaDB and the version is 10.6.21. Fine. So now we just install the server, MariaDB server. We can use it as a normal MariaDB server. Otherwise, we can also, let me admit, we can also use it as a Galera cluster. Okay. So if you want to set it up the Galera cluster, then you need to enable some parameters. For example, there is one parameter wsrep_on. If you mention that parameter equal to on, then it will enable the Galera cluster. Then you also need to tell the Galera library location. You need to tell the host in all that. Okay, there are certain parameters that we will configure. Fine. Now I have 3 servers and I have installed the MariaDB 10.6. Then the next step is I need to configure the cluster. Okay, I need to currently I just have the MariaDB servers on the 3 nodes. Just install the basic MariaDB server. I can use it as a server as well. Let's say, which means what I'm telling is if you want to do some master slave replication, that is possible. Here you can just, this will be the master and these 2 nodes will be the slave. You can just run the change master command. You can go with the async replication. But if you want to implement, configure the Galera cluster, then you need to install the Galera plugin. You need to configure that. Okay, that's what I'm telling here. Fine. So there are some basic parameters we need to configure. For example, 3 node. This is what we are trying to achieve. 3 node Galera cluster. 3 node Galera cluster. So let's try to prepare the CNF here itself in the host name -i. Let me get the IP for the 3 nodes. This is the 1 node IP and this is the second node. What is that? 19249. Next one is 99. Okay, 99. So let's assume this is the first node, first and second, and this is the third node. Okay, this is the third node. Fine. Now let's try to create the configuration file. Okay, so let's create for the configuration file for the cluster. First, we need to do w. This is the parameter wsrep on equal to on. Okay, we need to enable the Galera replication. This is one of the important parameter. You can enable the Galera replication by setting this parameter to on. Okay, then we can create that wsrep. We need to tell which location we have the Galera plugin. Okay, as I mentioned, Galera and this Percona XDB cluster both are natively supporting the Galera. Okay, so whenever you are installing the MySQL, MariaDB or Percona server, not MySQL, MariaDB or Percona server, it will also have the Galera library. Okay, so we need to find the location for that Galera library. So it should be under user inside the base directory. Okay, user is the base directory. There inside the lib. Inside the lib, let me see. Yeah, so here you can see Galera folder. Galera. Yeah, so this is the file, library file. Lib galera underscore smm.so. So this is the exact location and the library file name. Okay, fine. So now we need to add one more parameter, which is wsrep provider, which is providing this Galera replication. So there just we need to tell the location and the file name, the library file name. Okay, so these are the 2 parameters. Then we need to tell what are the host names. What are the host names are going to part of this Galera cluster. Okay, that we need to tell. How we can tell this? We have the parameter wsrep cluster address. Wsrep cluster address. So using that, you need to tell like I usually do with double quotes. I think gcom colon and with 2/. Then you need to tell the IP one by one. This is the first IP, and the second IP is with 33, right? 33, and the next one is 99. 99. So we have 3 IPs are going to part of this Galera cluster. So just configure that inside the WSREP cluster address. Okay. Then we have two node related parameter. Okay. We have need to tell the node related parameters, which is WSREP node address and WSREP node name. For example, WSREP node address. Node address is, let's say we are creating this config for the first node. Okay. So this is the WSREP node address and WSREP node name. WSREP node name. I think we need to give the same IP, but yeah, let's try with the different name. For example, Galera 1. Okay, if this is not going to work, we will use the IP. Okay, but I think it should work. Lately, I also see some issues with that parameter. Let's try it out. No issues. So we will, for the first node, we will have Galera 1. Second node, we will have the Galera 2. Third node, we will have the Galera 3. Okay, fine. Then there are two concepts, which is SST and IST. Okay, for example, here we need to understand three things: Gcache, SST, IST. Okay, so Gcache means, for example, we need to configure this size, Gcache size. Let's say I'm configuring 1 GB. Okay, my Gcache size is 1 GB. In this case, all the write sets which are processing by the server, that will be keep available in the Gcache. Okay, that write sets informations will be available in the Gcache. In case my node is down, let's say one of my node is down, I am sorry, 1 minute, 1 second. In case, let's say my second node is down. Okay, my second node is down for 15 minutes. My second node is down for 15 minutes. So in this case, two nodes are already functioning. Node 1 and node 3 is already functioning, and they are receiving the writes from the application. But still, my second node is down. But still, the first node and third node both are receiving the writes from the application. If for the 20 minutes, my second node is down, I am starting the second node at the 21st minute. Okay. So within this 20 minutes, if my application writes or happens less than 1 GB, in that case, when I am starting the second node, the lagging pending transactions, I mean the 20 minutes transactions, that will be applied from the Gcache. That will be applied from the Gcache. But during that 20 minutes, the writes which are received by first node and second node is more than 1 GB, then let's say 1.5 GB writes already happens. In that case, what happened? My Gcache size is 1 GB only, right? In that case, my Gcache do not have all these transactions, right? Do not have all these transactions. In this case, what happened? When I'm starting back the second node at 21st minute, it will do the snapshot transfer. That is called the SST. Okay. So we see two scenarios. If my 20 minutes data is available in the Gcache, then when I'm starting the second node, it will get the data from Gcache and it will join the cluster. That is called the incremental state transfer. That is called the IST. But if my Gcache do not have all this data, the data is already truncated. In that case, if my second node is need to join the cluster, but Gcache do not have the data, in this case, what what this second node will do, it will do the snapshot state transfer, which means it will do the SST method. There is one more parameter, SST method. Mostly we do Maria backup. It will execute the Maria backup on any one of the node, which is called a donor node. And it will do the Maria backup and copy the entire data to the second node. Then after the backup also, there will be some minimal transactions are missing, right? So that will be applied from the Gcache. SST will happen first. Then when the little data still there, that will be copied through the IST from Gcache. Then finally the node will join to the cluster. Got this right? So the main purpose of Gcache here is it will define whether your node needs to go for IST or SST. So SST will be the heavy operation. For example, if you have TBs of data, let's say you have 5 TB of data, and if you are joining the second node, in that time, when you are joining the second node, if it is going for SST, then it should take some time, right? Because your data size is very big, right? And when your SST happens, the node which is providing the data, let's say I am starting the second node, which is the receiver node. That node is not in the cluster yet. It will apply the backup, then only it will join the cluster. But when the second node is joining, node 1 or node 3 should be the donor, because they need to provide the data, right? That node will be called as a donor. That donor will also have some drawback, but that is improved recent releases. But previously, if you have some older MariaDB clusters, then donor also creates some issues. It will impact the transaction flow, certifications, it will create the contentions. There are some issues. Okay, fine. So when I'm doing the 5 TB of SST, let's consider the time. Time is very big, right? For example, if it is taking 1 hour for 1 TB, for 5 TB of SST, it will take at least 5 hours, right? Until that, you cannot use that node, right? So SST will be the heavy. So in this situation, setting up the Gcache size is very important. For example, from my experience, how we choose the sizes, we will monitor the 1 hour, how much data is being written in the heavy traffic time. Then we will consider to have it as a Gcache. And sometimes if you are doing the frequent maintenance activity, weekly once, if you are doing some maintenance activity, let's say I'm taking every node down for 30 minutes or 1 hour, then we need to make sure when I'm joining the node back, it should go for IST, not SST. So I need to calculate that for that 1 hour, how much data will be written. So based on that, some calculation, you can choose the right Gcache size to avoid the SST thing. Okay, fine. So this is about the SST, IST, and how the Gcache is playing the role with that both. And this SST will happen through this port, 4444 port. And in case if it is going with the IST, then that will happen to using this port, 4568 port. Okay, fine. So coming back to the coming back to here, this creating the config. So here I need to tell wsref SST method. Okay, so here you have different options. In case my node is going for SST, then which method it needs to use. We have for MariaDB Galera cluster, we have Maria backup, MySQL dump. You can also use MySQL dump, and you can use rsync. It will rsync the data from the donor to here. Okay, you have the different methods, but rsync will completely block your writes. It will just stop all the writes, and it will do the snapshot of your data directory from the donor. So in the donor, you cannot do anything. Okay, so rsync is not recommended. but it will be faster. Rsync is the faster approach, but you will have this block on your donor node. So depends on, in case if there is no rates, but you want to make the SST faster, then rsync, you can just have that rsync for that particular time, then later you can change it. Okay. And you can also use MySQL dump. MySQL dump is very slow. It is the single threaded operation, right? It is very slow, and that will also create the logs. We see the last session, right? That single transaction, how that MySQL dump created the logs with the single transaction with the other parameters. So the preferable method for the SST method is use Maria backup. Maria backup, which is the extra backup. We see that extra backup, right? So that is the fork with the MariaDB server, that is called a Maria backup. With the Percona extra DB cluster, we use WSRF SST method is extra backup. Okay, fine. Then we also need to provide the SST auth. For example, usually when we are taking the backup, we need to give the credentials, right? To connect the MySQL server, we need to give the credentials, right? So that we need to tell here. To perform the Maria backup, what is the username, what is the password? That's it. That we need to create one, and we need to give one here. Okay. Let's do that. For example, this is my first node. I'm going to make this first node as a primary. First, I'm going to bootstrap this node as first. So let me create one user. I'm giving all, but it don't need all privileges. There are some uh, select, reload, process. The minimal privileges only needed for the SST user. Okay. Don't do all. Grant all on to let's say SST at local host. SST user. You can give any name. Okay. Identified by SSTRE. Give any password. Okay, I just given this plus privileges. Fine. So now let me copy this, and my username is SST user. Here, SST user, you need to give colon, then password. Okay. So username, then colon, then the password. Okay. Then we need to give the cluster name also. So we provided the node name before. What is the name for that particular node? Now we need to provide the cluster name. WSREF cluster name. This should be common on all the configs. Okay, this should be the common. Cluster name, we can give any name. Let's say batch 4. Okay, we can give any name for the cluster name. Anything else I missed? I think SSTR, yeah, we have the WSREP slave threads. Like you can improve the parallelism bit for the Galera replication. We can do anyway, yeah, just to have that parameter, let me give WSREP slave threads. Yeah, and also we have one more important parameter, which is WSREP provider options. Okay, WSREP provider options. There only you can define most of the parameters. Like if you want to change your Gcache directory, that is possible. FC limit, how much transaction can be behind, that can be set over there. You can define the Gcache size using that option. Let's define some parameter here. WSREP provider options. Okay, so we can have some, yeah, let's set up the Gcache size. Anyway, my system resource is very low. But yeah, let's do, I am not sure. Gcache, I think it is correct. Yeah, let's see. I'm giving some 128 MB. That should be fine because my server is limited. And then let's define one more parameter, FC limit. Oh, I think it is GCS FC limit. Let's define, I think default value is 16 for this. Let's define 32. Okay, so eventually there are multiple parameters you can define here to changing the directory. You can go through the documentation for all the list of parameters, and we will also modify further this when we see that flow control thing. We will also modify few parameters here. But yeah, for now it is fine. Fine. I think we address most of the cluster related parameters. There is nothing much. We don't need the binary log. As I mentioned, for the Galera replication, that is happens based on the uh, write sets. It is not based on the binary log. Okay. So we don't need the binary log to be enabled. And let's do this bind address. By default, it is 127.00, right? So it cannot work. So bind add ress. I'm making it 0.0.0.0.0. Anything else? Yeah, server ID that should be unique. Server ID. Let's make it 101 for the first config and 102 for second and 103 for the third. Anything guys I am missing here? Any parameters I'm missing? Anyone have any parameter suggestion which will block the cluster? I think we cover all. Let's try. Okay, let's try. So what I'm going to do? Yeah. So now we at least we prepared some config now. So the next step is I need when I'm start I if I'm putting this config and if I'm starting back the cluster with the normal thing like service MySQL start, it on the first node it cannot work. Okay, you need to first node you should bootstrap. You need to bootstrap the first node in the Galera cluster. Then other nodes can be you can do with service MySQL start stop, and even on the first node you can do. In case all your three nodes are down, then you should when you are starting the first node of the Galera cluster, you need to bootstrap it. Okay, I will show that also how to bootstrap. Fine. I'm just copying this. Now, inside the cd etc MySQL, I'm going to remove all this thing. I don't need this, guys. Okay. ls-a inside the etc MySQL VR. Just I'm going to create vi my.cnf. So I'm pasting it. Yeah, and all this config should be the group MySQL D. MySQL D and so command of the I'm saving this, and on the second node I need to change few things, which is the wsrep node name should be Galera 2 and the node address should be 33 and the cluster name is fine. Yeah, and this server ID is 102. Okay, saving this, and on the third node, oh, on the third node 99, this is Galera 3 and server ID is 103. Okay, server ID is 103. Fine. So we have this config now. Now let me bootstrap the first node. Okay. So service MySQL status, which is active now. I'm going to stop this. I'm going to stop this. We might see some errors. Let's see. Okay. Stopped it. Then to bootstrap on the MariaDB cluster, you have the option Galera new cluster. Okay. This is one of the way to bootstrap, and you have also other ways. You can empty your gcom address, which means if you empty this address, this you can remove this three IPs. Just have like this. It then if you are just starting the service MySQL start, it will automatically bootstrap. Okay, that will also possible. And in the Percona DB cluster, I think there is some option. Service systemctl service bootstrap hyphen service at the rate service something is there. That is also you can do. But yeah, this is okay. So to bootstrap the first node, I need to execute the Galera new cluster. Let me do that on the first node. Oh, okay. There is a mirror. Let's see and try to fix it. It is error out within a seconds, man. I'm not sure what is the error. Only binlog format row is currently mixed. But even we did not enable the binlog, right? Okay. Let me try. Binlogs are also not needed. But yeah, it is just checking that parameter. By default, it is mixed, right? So let's just, we are not enabling the binlog, but binlog format equal to row. Just setting this up. I'm not sure why this needed without binary log, why it is checking. Fine. Let's see what is happening next. Doing. Okay, other error. Let me check. Okay, it is at least processed something. What is the error? Shutdown, complete, shutdown. Note, note. What is the error? Note, why note? Fail to locate the model. Hey, why it is searching Debian start? I'm not sure. Okay, I think that is not the error. Let's see. Hmm. Let me try to grab. Currently recovered only binlog format rows. Okay, that is we done. Where log, MySQL, MariaDB, nothing. Syslog. Okay, so here. uh, It is again reporting for the binlog format row. Nothing else is there, right? Let me tile the error log so that it will be helpful. Sudo su tile hyphen f var log syslog. Okay, now let's try to start. Galera new cluster. There is lot of things are happening. But yeah, I think from here, let's try to check what is happening. MariaDB, okay, WS, the cache debug, taking the parameter. No errors or warnings. It's okay. I'm okay. Warning. I was using Q in it, and it is fine. Should be fine. Okay, it is actually starting the MySQL, but later it is getting failed. It is actually started, but later WS node is not defined. Skipping exec node. Hmm. Warning. Warning WS rollback thread exists not indicated. User. Hey, what is the actual error, man? Should I try with the log warnings with more? Let me try. It is, but yeah, error should be reported, right? Let me check the startup script. I think it is trying to find the Debian start script on the Ubuntu service, MySQL status. This is going to be a debug session. Fine, let me check the startup script. DB. Yeah, so I think this we already removed that, right? X6 start. Let me try to command this. Yeah, I think we can command. So we removed all the config files inside slash etc MySQL, right? So I think this is trying to execute it. This etc MySQL Debian start is trying to execute, but that file is not there. We already removed it. So that could be the reason. Let's see. Yeah. Now again clear tail, clear tail, and let's try to bootstrap. Oh, we need to reload. Okay, let me try to reload. Systemctl daemon reload. So whenever we update the service files, we need to reload the config once, right? Huh. Just reloaded. Now let me try to start. Come on. Yes, it is started. So the issue is with that startup script, man. So we removed all that files inside the slash etc MySQL, right? Guys, anyone is there? Okay. So we removed all those files, right? So we just created only this my.cnf file. So by default, we had that conf.d, MariaDB.cn conf.d, and Debian start. So that Debian start is also available in that startup script. So that is what it is trying to call that script, and it got failure. Okay. So that is the reason. So how I found that is, I was seeing that somewhere. Let me show you. Grep DB. Yeah. So Debian start. I was seeing that somewhere. Debian start. Debian start. Yeah, yeah. So here you can see I was seeing there is actually not exact error, but I noticed this one. This no such file directory. So that is what I suspected that could be the reason. But there is no solid error printed in the error log. That is sure. It is under the node section only. So I just see this no such file directory. So I thought that could be the problem. Fine, anyways. Okay, so now we just bootstrap this. It is completed without any error, right? So you can log in the MySQL. Let me close this. So once you done, show variables like wsrep. So you can now find all the parameters related to wsrep now. Okay. But before that, it should not be there in the normal MySQL. For example, show variables like it should not be there. Let's see. Oh, it is there, but it is not configured. But if you have this, what is that? Percona cluster, you will not find this WSREP related parameters until you have installed the Galera plugins. Okay. But yeah, we have this here, but everything is just have the default parameters. Fine. So now you can see here it is configured all this parameter. Okay, even the WSREP node name is also taken, right? WSREP node name. Yeah, that SST auth is with star, but if someone have your Linux access, OS access, they can still get it from the my.cnf. Uh, yeah, so node name is taken the Galera one. Fine. So here there are some status parameters also that is important to understand your cluster status. For example, show global status like wsrep wsrep and adding the percentage. So if you see this status parameter now, so let me try to tell about some important values. So this cluster status, it should be primary so that your node is healthy and it is joined in the cluster and it is ready to participate in the certification process. Okay, sometimes you will see non-primary. Okay, if this node is going to be the donor, then it will make it as a non-primary thing. Okay, and sometimes it will have the disconnected. Okay, if some network partition happens between the nodes, that time you will see some disconnected errors also in this status. If it is primary, then your node health is okay. This is WSREP cluster size is one of the important value we usually check to see how many nodes are part of the cluster. Okay. Let's say we have 3 node cluster, but now you can see this is one, which means this only one node is available in the Galera cluster now. Because yeah, that is correct. Because we did not join the other 2 nodes yet, right? Currently, we just bootstrap this one nodes. Now you can see this cluster size is one. When we adding the other 2 nodes, you will see the incremental here. Okay. And the CVS state is also important. You can check it should be the operational to understand your cluster health. And there is something incoming address here. You can check how many clusters are connected and actively participating in the replication certification process. So when you added the other 2 nodes, you will see the other 2 nodes IPs here. So you will get the host names of your uh, nodes which is in the same cluster. Okay, and this is synced. This is also one important thing. Sometimes it will go to desync mode. That is mostly when your node goes to the donor, and if it is more than the lagging more than flow control limit, that time you will see this local state command is going to be the desync status. Okay, and there is one more thing. Last committed. Let me check. Yeah, so this local receive queue, this is also one of the important parameter to check. You might see some numbers here. Let's say 20 or 25 means this transaction is, sorry, this server is lagging 25 write sets. Okay. If your node is lagging some write sets, then you can check this parameter to understand how much write sets your node is getting lag. Okay. So yeah, this is synchronous replication, but still we are speaking about the lag, right? That will cover and say under the flow control thing that we will see later. And WSREP last committed, there is one parameter. Let me check. WSREP last committed. Yeah. So this is actually the transaction number. So this is also the XID number. In case if you want to do some replication, you want to find the exact binlog file and position, then you can search this XID number within your binary log. There you can find the binlog file and position. And if you want to make sure your cluster is up to date, your cluster is completely caught up, then you can check the status, wsrep last committed status on all the three nodes. If it is showing the same number, then all your clusters are caught up. They are completely synced. There is no issues with that. Okay. But if you are seeing some different number, let's say here if it is 4 and here this node if it is 2, which means this node is lagging 2 transaction. Okay. So you need to, in case if you are taking some downtime, you want to do some activity in that kind of scenario, you can make sure this last committed parameter, I mean this value is same across all the cluster to ensure your all your cluster nodes are completely caught up. Okay, so this is also one of the important status parameter to be checked. Fine. So now let's do add the other two nodes. Okay, I think that should be quick. Let me. So we need to service MySQL status. We need to we need to disable that line, otherwise it will create the error here as well. Just Debian start. Where it is, where it is. Let's hide that. Exec, exec. Yeah, so here it is. I'm just hiding this parameter. But yeah, here one more thing is you noticed, right? Like we did not have the bin log, but still we need to set the bin log format equal to row. For example, let's see show binary logs. See, you are not using the binary logging. We did not use the bin log, but still we need to bin log format. We need to set this bin log format equal to row even without the bin log, right? So this is one thing interesting. Fine. We just disable that, and also we need to enable the parameter bin log format row here as well. Bin log format equal to row, right? Yeah, I think we are good. Service MySQL stop. Yeah, we need to do this daemon reload. This is when we updated the service config file, right? This file. So when we are updating the services files, we need to reload the daemon. Now let me start back. It should be okay. Okay, we have the error. Let's see. Oh man. So this is what I usually do. Do some pre exercise before the classes. But today I did not made anything. But yeah, so that we are handling with the error. But yeah, it is interesting to fix. Let's see what is happening here. Aborted code MariaDB terminated. Not sure why it got terminated. Okay, error is here. Fail to read SST Maria backup. Process completed. File to prepare Maria backup. SST unrecoverable. What happening? SST request. SST is getting failed. Yeah, so when we are adding the node firstly, we are noting that we are adding this node first time, right? So that time, firstly, when we are doing, it will go for SST until we modify the grass.dat file. That is different topic. But yeah, here it is failing. Let me okay, I think let me check the Maria backup is installed or not. apt dp. kg-l grep-I Maria. Okay, I think Maria backup is not there, right? That could be the reason. Let me search MariaDB backup, I think. Okay. So, yeah, MariaDB backup. Let me install on all the nodes, all the three nodes we needed. Command apply. Clear. apt get install MariaDB backup. First node, it is not needed. That is what it did not error for that, because first node is not going to do SST with any of the node, because that is the first node, right? We are just bootstrapping it. That's it. So it did not error out for the Maria backup. But when we are adding the second node, it needs to SST. But the Maria backup is not there, so it got the error. Now let me try again. Service MySQL start. Yeah. So this is done. Now we can verify this by checking the cluster size. Yeah. So now you can see WSREP cluster size. Yeah, this is previously 1, right? Now it is 2, which means there are 2 nodes now in the cluster. And you can see this incoming address also, 33 and 140. Both the IPs are here now, right? Fine. Now let's do the third node. Here also, I need to update binlog format first. Binlog format equal to row, and then that startup script service MySQL status. The startup script location is this one. Let me update that. Debian. Yeah. So let me just hide this. Then we also run that daemon reload, right? What is that system? Systemctl daemon reload, I think. Yeah, reload. Then service MySQL start. We already installed the Maria backup. Cool. So this is also done. So now you can see again the cluster size is still 2. It should be 3. Let me check. Show global status like WSREP. Oh, I think we did not stop that node, right? That is the issue. Cool, cool, cool. This is 2. See, we did not stop that node. It is already running, right? So let me stop and start. Yeah, start. Hmm. Come on. Taking long time. You can also monitor the status here. If it is going for SST, yeah, it is done. Anyway, let's see. Yeah, you can see the cluster size over there, right? Cluster size is 3. And now this incoming address also, you can see the 3 nodes address. Yeah, and you can check the status on any node. Okay, don't, yeah, I'm checking the first node, right? But you can check any node which is part of the cluster status, like just W0. You can check any node of the cluster. It should be reported the same status. Okay, until the cluster status should be same. The node status related parameter may be different. Cool. So this is what the setup. Now, yeah, you may already do this, but yeah, let's try database created, and here if you see show schemas, we have free here, create database, batch 4. You can see the show schemas, batch 4 here. So you can write on the any node, it will be replicated across the nodes in the same cluster. Okay. And writing on all the nodes is also not recommended all time. If your write is heavy, then I would recommend to use the single node for the writes to avoid we see the architecture, right? The deadlock thing. You may face frequent deadlocks, related errors when you are writing all heavily on all the nodes. That time you will face some issues. Yeah, so this is about the setup. We were managed to complete this. I was doubted about the setup, but yeah, we managed to do this. So I think in the next session, I don't want to mix much. So at least we need one more session for this Galera. So what I'm thinking is there is only one session pending in the backup also. So maybe in the next class, I will what I can do, I can finish this Galera thing. Then we can the next class we will continue with this Galera so that it will be there will be the continuity, right? So after we finish this Galera, then we will spend one class for the remaining that MySQL shell utility backup and MyDumber backup do. Then after that we will kickstart the performance sessions.